Concentrating Solar Power Energy by Ice
and Eva.
Concentrating Solar Power Energy, or CSP Energy, is a renewable energy system that creates completely clean energy, free of pollutants such as carbon dioxide and sulfur. Widespread implementation of this technology has the potential to give the stratospheric ozone time to rebuild itself while using a very low amount of resources. This technology uses mirrors and tracking systems to focus sunlight from a large area into a concentrated high-energy beam. The CSP then uses this heat, stored most often in molten salt, to evaporate water and create steam to turn turbines that generate electricity.
CSPs have several different designs, such as the parabolic trough, power tower, and the dish engine system. Blub blub. Blub.
The parabolic trough is a large mirror shaped like a U, connected in long lines that track the sun throughout the day. Its curved shape sends the sun's reflected heat onto a receiver, and the receiver tube is filled with a fluid that holds heat well. In this process, it's most often synthetic oil. The heated oil boils water to create a steam to turn a turbine, which creates energy. After this process is completed, the oil and the steam are both recycled back into the system. Blub, 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 blub. This is a power tower. It uses large flat mirrors to focus heat onto a receiver. The receiver sits on a tall tower and contains the heating fluid. Power towers most often use molten salt as their heating fluid. In the same way as the parabolic trough, heated water is used to generate electricity. This heating fluid is recycled back into the system just like the parabolic trough. Blub, blub, blub. Lastly, we have the dish engine system. The dish engine system uses giant mirrored dishes to concentrate heat onto a receiver, mounted onto the focal point of the dish. This system heats helium or hydrogen in tubes that run along the outside of the engines. As concentrated sunlight falls onto the individual receivers, it heats the gas in the tubes to very high temperatures, causing hot gas to expand, driving pistons that turn a crankshaft and drive an electric generator. Blub, 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 blub.
One problem often faced when constructing CSPs is that they require large amounts of land. Therefore, they are often located in open plains or deserts. Furthermore, these locations allow optimal sun exposure. One big problem of solar energy that CSP systems address is producing energy at all hours of the day. Because CST systems collect thermal energy and then use it to power a generator, energy can be stored between the two processes in the heating liquid, providing energy without sun. Heating liquids like molten salt can hold a temperature of around 550 degrees Celsius, whereas synthetic oil can hold around 400 degrees Celsius to supply energy long after the sun has set.
It costs on average 10 cents per kilowatt hour to run a CSP system and is projected to lower to 5 cents per kilowatt hour by 2030. The only political or economic obstacle in the way of using this system is the use of space, along with diverting funding for CSP energy from other more convenient energy sources.
Environmentally, CSPs have very little impact. Heating liquid is often recycled or reused after a plant is decommissioned, and in addition, there is some habitat intervention that occurs just with the nature of building any structure. And furthermore, birds sometimes fly into the highly concentrated light. At the Avampa CSP plant in the US, this caused 133 bird deaths within 6 months. But besides from that, there is little recorded large habitat intervention.